Imagine this. Something's barreling through our cosmic neighborhood, our very own solar system, on a path so improbable, it makes you blink twice. We're talking less than a 1 in 20,000 chance of it just happening naturally. But here's where it gets truly wild. This thing, whatever it is, isn't just passing through, it's speeding up, on its own. No visible engine, no exhaust plumes, just accelerating. It's got scientists scratching their heads, and not just a little bit. We're talking about a fundamental, mind-bending question. Are we on the verge of uncovering a brand new law of physics, one that rewrites our textbooks? Or, and this is the thought that sends shivers down some spines, are we actually observing the unmistakable signature of an alien intelligence at work? This isn't just another space rock. This is 3I/Atlas, and it's challenging everything we thought we knew. The date was July 1st, 2025. Just another day in the cosmos, or so we thought. But then, the Automated Asteroid Terrestrial Impact Last Alert System, or ATLAS as it's more commonly known, picked up something faint. A tiny smudge moving through the blackness, but moving way too fast. Fast enough, in fact, to make it clear this wasn't just another resident of our sun's sprawling family. This was an interloper, an outsider. Within hours, the dedicated folks at the Minor Planet Center, the International Clearinghouse for Small Body Observations, were running the numbers. They ran them once, then twice, then triple-checked everything with a meticulousness that would make a Swiss watchmaker proud. Finally, quietly, they posted its official designation, 3I/Atlas. That key 3I's prefix, it's a big deal. It means this is only the third confirmed interstellar visitor we've ever seen. Ever. Let's put that in perspective. The first, Oumuamua, showed up in 2017. It was cigar-shaped, tumbled oddly, and gave us a mild scare, prompting a flurry of "is it aliens?" speculation before settling back into the realm of natural but weird. Then came 2I/Borisov in 2019, which, bless its heart, looked and behaved exactly like a textbook comet should. Nice and normal. But 3I/Atlas, oh no, 3I/Atlas absolutely refuses to fit either mold. Its sheer speed relative to the sun is jaw-dropping, almost 40 kilometers per second. That's enough velocity to definitively escape our star's gravitational embrace entirely, heading back out into the galaxy. Yet, instead of just a simple, sweeping hyperbolic arc that would take it far from our planetary plane, this object threads the needle, slicing through the solar system with a tilt of barely 5 degrees to the ecliptic. That's incredibly close to the plane where all our familiar planets orbit. It's on a grand tour, brushing past Venus, Earth, Mars, and Jupiter. Think about it. An object from another star, plunging into our system and then aligning itself almost perfectly with our planetary traffic. Back-of-the-envelope statistics, the kind that make astronomers lean back in their chairs and whistle, say the odds of that exact geometry happening by accident are an astonishing 1 in 20,000. Initially, many astronomers just shrugged. Space is vast after all, and improbable things happen all the time. But then, the acceleration reports started trickling in, and that's when the shrugging stopped. Now, comets are known for their little propulsion systems. As they get closer to the sun, they warm up. Ice turns directly into gas, a process called sublimation, and that gas vents off, giving the comet a tiny, gentle recoil. We call this outgassing, and it's a perfectly natural phenomenon, measurable only with our most sensitive instruments. It's like a tiny natural thruster. But 3I/Atlas, its acceleration is in a whole different league. It's gaining an extra 5.9 times 10 to the -5 astronomical units per day squared at 1 AU from the sun. That might sound like a mouthful of scientific jargon, and on paper it looks tiny. But for an object estimated to be less than 6 kilometers across, that translates to a continuous, sustained push. We're talking about the equivalent of a city bus-sized rocket engine firing 24 hours a day, 7 days a week, without ever running out of fuel. That's not just a gentle nudge, that's a serious kick in the cosmic pants. Conventional wisdom for any accelerating comet immediately points to sublimating ice. If it were water ice, we'd expect to see clear spectral signatures of water molecules, maybe even cyanide or carbon, as these are common volatile components in comets. So, what did the spectroscopes tell us when they peered at 3I/Atlas? Nothing. Zip. Zero. All we get is a faint reddish dust and a ghost-thin tail. No telltale chemical fingerprints of outgassing. It's like a car accelerating without burning any fuel and with no exhaust pipe. This lack of traditional cometary exhaust puts a massive wrench in the works. If mission control on Earth can't throttle an invisible engine, then what's going on? Theorists, always eager for a challenge, did the math, and what they found was truly compelling. The acceleration vector points almost exactly opposite to the sun. This is the hallmark signature of controlled propulsion, of something actively pushing itself away from the star's radiant energy. Harvard's Avi Loeb, a name you might recognize from the Oumuamua debates, and his colleagues quickly crunched some numbers. They calculated that this kind of acceleration could allow for a reverse solar Oberth maneuver. Think of it, diving close to the sun, using its immense gravity to slingshot, but then firing thrusters against the direction of travel to brake hard. This isn't just theoretical, it's a known high-thrust technique that could allow an object to drastically change its trajectory, or even remarkably, stay bound to the solar system forever, rather than just passing through. Is 3I/Atlas a natural fragment, a cosmic anomaly that defies our understanding? Or is it something far more sophisticated, a probe under deliberate control? The data, frustratingly, remains stubbornly neutral, offering tantalizing hints without definitive answers. Of course, not everyone is rushing to declare an alien presence. The scientific community thrives on skepticism, and rightly so. At NASA's Jet Propulsion Laboratory, home to some of the brightest minds and most advanced trajectory modeling software, they immediately reran the numbers. They threw every known solar radiation pressure model at 3I/Atlas's trajectory, trying to find a natural explanation. Their conclusion? They insist that the faint coma we do see, however anemic and devoid of typical cometary gases, could still be enough to shove a lightweight nucleus. Their best fit size for the object is under 5.6 kilometers, and they propose it might be hollow or incredibly porous, releasing micron-scale grains of dust. These tiny particles could reflect sunlight, creating the appearance of a tail and exerting a subtle pressure. Yet they could be too small or too diffuse to show clear spectral fingerprints of common cometary volatiles. It's a clever idea, suggesting the anomaly isn't quite as anomalous as it seems. Meanwhile, across the Atlantic, the European Space Agency's Near-Earth Object Coordination Center offers another dose of scientific caution, reminding us of observational bias. Think about it. We only really spot interstellar visitors when their paths happen to graze ours. So, they argue, perhaps tight inclinations like 3I/Atlas's 5-degree tilt aren't actually rare at all. Maybe they're quite normal for interstellar objects, but we simply haven't sampled enough of them to know. We're essentially looking through a tiny keyhole in the vastness of space, and what we see might not be representative of the whole picture. They also point out a crucial detail. 2I/Borisov, that perfectly ordinary textbook comet, was also an interstellar visitor. That's proof, they argue, that nature can and does make normal interstellar comets. So perhaps 3I/Atlas just sits somewhere along a continuum, a fascinating midpoint between the truly weird Oumuamua and the wonderfully boring Borisov. Nothing alien required, they suggest. As the old adage goes, extraordinary claims need extraordinary evidence, and a statistical tale of 1 in 20,000, while certainly rare, is still not zero. It's not impossible. But what if the acceleration isn't artificial? What if it's natural, but still utterly baffling? If that's the case, then 3I/Atlas might just rewrite the entire physics rulebook. For decades, modified gravity theorists have been on a relentless hunt for a fifth force, a fundamental interaction beyond the four we currently understand: gravity, electromagnetism, and the strong and weak nuclear forces. They propose this force might only kick in at incredibly small, sub-kilometer scales, precisely the size range of 3I/Atlas. Could this object be experiencing the subtle tug of a previously unknown cosmic influence? Others propose even more exotic ideas. What about dark matter microhalos? These are hypothetical tiny clumps of dark matter, the mysterious substance that makes up most of the universe's mass but doesn't interact with light. The theory suggests these microhalos could be trapped inside the nucleus of 3I/Atlas. As they annihilate, a process that would release immense energy, they could heat pockets of ice within the object asymmetrically. Imagine a tiny internal stealth thruster, constantly firing from one side as dark matter converts into energy, creating that unexplained push without any visible exhaust. And then there are the quantum vacuum interaction models. These theories toy with the idea of photon recoil from the object's own thermal glow. It's a bit like a flashlight pushing itself forward with the light it emits, but on a quantum level, interacting with the very fabric of space-time. Each of these explanations, while scientifically intriguing, carries heavy baggage. They require us to invoke unseen particles, finely tuned couplings that seem almost too perfect, or energy budgets that border on the realm of science fiction. Yet, we have to remember, nature has surprised us before. Our understanding of the universe is constantly evolving. When Oumuamua zipped away, leaving a trail of unanswered questions, the same kinds of debates flared up: new physics, alien tech. But then, for lack of fresh data, those debates cooled, and the scientific community moved on. 3I/Atlas, however, offers us a second chance. It's not just another weird object, it's richer, stranger, and perhaps more insistent on challenging our preconceptions. It's forcing us to confront the boundaries of our knowledge. Alright, let's go there. Let's truly entertain the techno scenario. What if 3I/Atlas isn't just a rock, but a piece of technology? Imagine a probe designed by an advanced civilization, specifically engineered to survey life-bearing systems like our own. Such a craft might perform a dip close to a star, using its gravity for a precision maneuver. It could even aerograte, a fancy term for using the upper atmosphere of a terrestrial planet to slow down and adjust its trajectory, perhaps around Venus or Earth. After such a delicate dance, it might then settle into a long, elliptical parking orbit, patiently observing. The low 5-degree inclination of 3I/Atlas's orbit, so close to our ecliptic plane, becomes incredibly significant in this context. It keeps the craft right where the action is, near where rocky worlds and potential observers like us tend to cluster. It's a prime vantage point. And that dust cloud released on approach, it could serve a dual purpose. First, camouflage, making it harder for our telescopes to resolve. Second, and crucially, as a micrometeorite shield, protecting the delicate craft from the high-speed grit and debris that constantly pepper our solar system. And that reddish hue we observe, perhaps it's not just random dust. Maybe it's a deliberate broadband absorption coating designed to avoid optical glint, making it even harder to detect and analyze. Now we have to be honest. We have no photographs sharp enough to resolve any specific features. No nozzle, no solar sail, no radiator fin. Just a fuzzy blob of light, a point in the distance. But remember the old saying, absence of evidence is not evidence of absence. Especially when the object is so small, so distant, and will soon slip behind the sun this December, becoming utterly unreachable by our current instruments. Critics, of course, are quick to invoke the dark forest interpretation of the Fermi paradox. This chilling theory suggests that advanced civilizations in the universe might choose to stay silent, even eliminate potential competitors preemptively, because announcing your presence is an inherently dangerous act. If 3I/Atlas is indeed a scouting probe, a silent sentinel, should we be shouting hello into the void, or should we keep quiet, maintaining our own dark forest posture? The mere possibility of alien technology has sparked closed-door discussions in policy circles around the globe, reviving protocols that were originally drafted and then shelved after the first Oumuamua scare. This isn't just science fiction anymore, it's a real-world dilemma. So, how do we solve this cosmic riddle? The clock is ticking. Within weeks of its discovery, radar campaigns using the Deep Space Network's largest dishes were green-lit. These massive antennae are essentially trying to bounce radio waves off the object and catch the faint echo. But it's a Herculean task. The return signal is incredibly weak because the object is small, fast, and already outbound. It's like trying to hit a bullet with another bullet, in the dark, and then listening for the ping. Optical observers, the folks with the powerful telescopes, are planning an intensive photometry sprint before 3I/Atlas reaches perihelion, its closest approach to the sun. They're hunting for any millisecond flickers in its light, hoping to betray rotation, or perhaps even the glint of onboard power systems. And here's a cool part. Amateur astronomers with 30-centimeter scopes can still catch it glinting near magnitude 14. Every light curve they feed into citizen science repositories adds to the collective data, a truly global effort. But let's be realistic. If a future mission is ever going to intercept this thing, the window is closing, and closing fast. Launch opportunities for a New Horizons-class flyby, similar to the mission that visited Pluto, are shrinking to months, not years. Why? Because 3I/Atlas will exceed Voyager's escape speed, the speed at which our fastest probes leave the solar system, by early 2026. Catching it would require something extraordinary. Enter the beam sail probe concept. Imagine a tiny spacecraft equipped with a massive ultralight sail, accelerated by gigawatt laser arrays positioned in Earth orbit or on the moon. This isn't science fiction. It's a concept being actively researched. Such a probe could, in theory, overtake our mysterious visitor within a decade. It could then sample its dust, radio home high-resolution spectrograms, and perhaps even send back images. The price tag for such an endeavor, north of $20 billion. The political will to fund it, non-existent. For now, until hardware meets opportunity, until we decide as a species that this mystery is worth the immense investment, we remain stuck with remote sensing and educated guesses, peering from afar at a cosmic enigma. You might be thinking, this is fascinating, but what does a weird space rock have to do with my life? Well, quite a lot, actually. Interstellar objects aren't just cosmic curiosities, they're essentially cosmic postcards. Each one carries raw material from a different stellar nursery, a different star system far beyond our own. Studying them lets us test a fundamental question. Is our solar system's recipe typical? Are the building blocks of planets and life similar across the galaxy? If 3I/Atlas is a natural object, its weird orbit and composition could hint at unseen planetary architectures in its birth system, giving us clues about how other solar systems form and evolve. But if it's technological, if 3I/Atlas proves to be a calling card from an alien intelligence, it would be a revelation that would galvanize engineering programs worldwide. It would prove, beyond a shadow of a doubt, that toolmakers have solved interstellar travel. Think about the implications. Breakthroughs in propulsion, materials science, energy generation, all potentially inspired by understanding how they did it. It would be an intellectual tsunami, transforming our scientific and technological landscape. Either way, the data we collect from 3I/Atlas, from its trajectory to its subtle acceleration, refines our models. These aren't just abstract calculations. These are the same models used to track near-Earth asteroids, the very ones that could one day threaten our cities. Better understanding of orbital mechanics and non-gravitational forces makes our planet safer. In fact, spin-off algorithms developed to track such fast-moving, elusive objects are already improving the accuracy of our GPS systems and enhancing satellite drag forecasts, helping us manage the ever-growing constellation of satellites orbiting Earth. Curiosity, it turns out, always pays practical dividends, often in ways we never initially expect. If these big questions about aliens, new physics, and the very nature of reality fire up your neurons and make you want to know more, then hit that subscribe button and ring the bell. We've got more cosmic mysteries dropping every single week. And if you want to dive deeper into the first interstellar visitor, Oumuamua, check out the playlist linked below. It's the perfect primer for tonight's dinner table debate. The next few months are absolutely critical for 3I/Atlas. Between now and December 2025, the object will perform a dramatic slingshot around our sun, rounding perihelion, its closest approach, at a distance of only 28 solar radii from the sun's surface. This is where solar heating will peak, reaching its absolute maximum. Any hidden volatiles, any pockets of ice that have remained dormant, should finally reveal themselves, possibly creating a fresh, measurable dust jet that we can analyze with our spectroscopes. Or perhaps the surface might simply crack under the immense thermal stress, revealing something entirely new. It's a make-or-break moment for the natural comet hypothesis. Post-perihelion, on its outbound leg, 3I/Atlas will cross Jupiter's immense hill sphere, the region where Jupiter's gravity dominates over the sun's, in March 2026. This is another crucial observational window. Dynamicists, the scientists who study how objects move under gravity, are hoping that the giant planet's gravitational influence will bend 3I/Atlas's S-path by a measurable few arc-minutes. If they can detect this subtle alteration, it would allow them to pin down the object's mass and density with far greater precision, offering invaluable clues about its internal structure. After that brief but critical encounter, the visitor will simply head for the constellation Pegasus, fading beyond magnitude 20 by 2027. That's too faint for even most professional telescopes to track consistently. Once it slips from sight, retrieval becomes a job for our grandchildren, or perhaps even further descendants, unless, of course, we manage to act decisively in the next incredibly narrow launch window. The universe, it seems, isn't waiting for us to make up our minds.
For 10,000 generations, humanity has stared into the heavens, each culture, each individual, largely assuming that the cosmos, in some profound way, revolved around us. Then Copernicus came along and moved us off center, telling us we weren't the physical hub of creation.
Centuries later, Hubble expanded the stage, revealing a universe of billions of galaxies, each containing billions of stars, making our sun just one tiny speck among countless others. And now, 3I/Atlas dangles an even more profound possibility, that we are neither alone, nor perhaps the pinnacle of intelligent life. The psychological jolt from such a revelation could easily dwarf the scientific payoff. History shows us that cultures react to paradigm-shifting discoveries in wildly various ways, with intense curiosity, with paralyzing fear, or sometimes with renewed cooperation and a sense of shared destiny. The choice of response, should 3I/Atlas turn out to be something truly extraordinary, is entirely ours. But we can only make an informed choice if we confront the data honestly, free from sensationalism, free from the easy answers of conspiracy theories. Healthy skepticism, not arrogant dismissal, is the compass that will guide us through these uncharted waters. It's about being open to possibility, but demanding evidence. So, what is 3I/Atlas? Is it truly just a 1 in 20,000 fluke of ice and dust? A cosmic anomaly that stretches our understanding of natural processes? Is it a silent messenger bearing entirely new physics, hinting at forces or particles we haven't yet discovered? Or, and this is the question that keeps many awake at night, is it a calling card from minds unlike our own? A piece of technology from a distant civilization? Right now, if we were keeping score, the scoreboard would read something like this. Orbital oddity, check. Unexplained acceleration, check. Zero direct evidence of little green appendages or flashing lights, also check. The universe, as it always does, keeps its secrets close, teasing us with just enough anomaly to stay awake at night, wondering. Whether future textbooks list 3I/Atlas beside Halley's Comet as a natural wonder or under the monumental heading of First Contact remains utterly undecided. Until the data speak louder, until we get more definitive answers, keep watching the skies, and maybe, just maybe, keep a towel handy. You never know when you'll need it.